The last time a bee flew too close, you moved. Maybe you stepped back. Maybe you raised your hand slowly or held very still. Or did that particular thing people do around bees. A kind of suspended alertness, breath half held, eyes tracking the insect until it passes. Maybe you felt the specific mixture of alertness and restraint that most people have been carrying since childhood without anyone ever explaining why or where it came from, or whether any of it actually did anything. What you didn't know is that the bee had already made her decision before you moved. By the time she was close enough for you to notice, close enough that the hum became something you heard individually rather than as background, she had already completed her assessment. She had measured your movement pattern. She had processed the concentration of the carbon dioxide you were exhaling. She had registered the visual contrast of your clothing against the backdrop of the garden. She had run everything she needed to run through and arrived at an answer. You were not a threat. She moved on, not because you held still. She had already moved on. You were processed, classified, and set aside in less time than it took you to register she was there. You were, from her perspective, a large, warm obstacle between her and the lavender, and she navigated around you the same way she navigates around a fence post. Almost everything most people believe about why bees sting is missing something so fundamental that the picture it creates is almost backwards. And what's actually true is stranger, more specific, and more interesting than the fear that most people carry for their entire lives without ever examining it. If you're new here, subscribe before you go. New video every week. Stay until the end, because the last section reframes something you've probably believed since you were a child, and once it shifts, it doesn't shift back. Start with what most people think they know. The common understanding goes something like this. Bees sting when they feel threatened. Stay calm, don't make sudden movements, don't swat, and you'll probably be fine. The bee is a small creature with a weapon, and she deploys it when she feels endangered. This is the version most people receive as children and carry through their lives as a complete explanation. It is not complete, and the part it is missing changes the entire picture. The stinger of a worker honeybee is barbed. This is the detail that changes everything. When that barbed stinger penetrates mammalian skin, human skin, the barbs catch in the tissue. The bee cannot pull free. She can pull against the catch, and she does, and what happens as a result is that the stinger tears free from her abdomen along with the venom sac, part of her digestive tract, and portions of her nervous system. She flies away from the encounter, missing the organs she needs to survive. She will live for perhaps 60 more seconds of flight. She will be dead within minutes. There is no scenario in which a honeybee stings a person and then goes home. Every sting is fatal. Not a risk of injury, not a bad experience. The decision to sting is the decision to die. Which means that the actual threshold for stinging is not, she felt mildly threatened. It is not, the situation felt uncertain. The threshold is closer to, this situation has become so immediately, specifically dangerous to the survival of the colony that spending my remaining life on this response is the correct calculation. Researchers at the University of Sussex studying the mechanics of honeybee defensive behavior documented the conditions that reliably trigger a sting response. Direct, sustained physical assault on the hive entrance, a predator actively attempting to breach the colony structure. Direct physical compression of the bee's own body, being sat on, stepped on, grabbed, squeezed. Environments saturated with alarm pheromone, where other bees have already stung and the chemical signal to defend has spread through the nest to a critical threshold. These are the conditions that tip the calculation. A person standing in a garden, moving at ordinary human speed, breathing, wearing clothes, reaching toward a plant, does not register as any of those conditions, does not come close. There is one variable that changes this calculation significantly, and it is worth understanding because it explains almost every exception to the pattern. Alarm pheromone. When a bee stings, the act of stinging releases a chemical signal, isoamyl acetate, which smells faintly of bananas, that broadcasts to every nearby bee, "Something here is worth defending against." If that pheromone is already present in high concentrations in the environment because a nest has already been disturbed or another bee has already stung, the threshold drops for every bee in the area. They are not angrier. They are receiving a signal that says the defensive calculation has already been made by another individual and found warranted. They update accordingly. This is why disturbing a nest, knocking it, striking it, running a lawnmower repeatedly past an in-ground colony, produces a response that feels aggressive when what is actually happening is an alarm pheromone cascade. Each sting releases more signal. More bees read the signal. The response amplifies. The colony is not attacking because it is malicious. It is responding to chemistry. Remove the pheromone, and the response collapses. A person who leaves the vicinity of a disturbed nest for 20 or 30 minutes, allowing the chemical signal to disperse, returns to an environment where the alarm threshold has reset. The same bees at the same nest will not pursue them. They were never hunting. They were reading a signal, and when the signal clears, they stop. What the bee registers when she encounters a person in the course of a foraging flight is a large, warm-bodied, slow-moving object, something to navigate around. She has been navigating around large objects her entire life. You are, in the processing architecture of her threat assessment system, in the same category as a wheelbarrow, a garden gate, a dog sleeping in the sun. The assessment is over in under a second. She has already moved on before you finish noticing her. Now, the assessment is more sophisticated than big thing, ignore. Research from the laboratory of Lars Chitka at Queen Mary University of London, published across more than a decade of work on bee sensory and cognitive capabilities, documented that foraging bees process multiple threat-relevant signals simultaneously: movement speed and pattern, the chemical profile of the air immediately around a potential threat, visual contrast ratios, the sound frequencies produced by nearby objects. The bee is not responding to a single trigger. She is building a composite picture. What this means in practice is that the assessment adjusts for context. A large object moving slowly and steadily, a person walking, a dog wandering, scores differently from a large object making rapid, unpredictable movements. A person who is sweating heavily or wearing floral perfume that mimics the chemical profile of a food source creates a slightly different read than someone who isn't. Dark colors, which are how bears look and have been registering as visual threats to bees for millions of years, produce a different initial response than pale colors. None of these factors individually push a calm forager to sting, but they are all being read, simultaneously, in fractions of a second. The bee you saw this morning built a picture of you out of all of these inputs before you moved. What came back was a probability assessment that said, low threat, not worth engaging, continue toward the flower. She did not then reconsider when you held still. She had already decided. You holding still was irrelevant to the calculation. The calculation was done. This is the thing that I find genuinely difficult to absorb, even knowing the research. Not that bees are capable of this kind of multivariable rapid assessment. The evidence for that is thorough and long-standing. But that it was happening around me, every time a bee flew close, for my entire life, and I had no idea. Every bee that has ever flown near your face and then moved on was not sparing you because you happened to behave correctly. She was completing a calculation she had started before you noticed her, and finding you, specifically, not worth the trade. The trade being her life for whatever damage a single sting would cause. You were never the target. The flower was the target. Let's talk about the 6 weeks. A worker bee in your garden this summer will live for approximately 6 weeks from the day she first left the hive. That is the entire span. 6 weeks in the warmth, foraging, dancing her routes, carrying pollen, flying corridors between the hive and whatever patches of flowers she has been assigned to or found on her own. After 6 weeks, her wings are worn down from use. Her body begins to fail. She will die outside the hive on a foraging run, and her sisters will not retrieve her. She will simply not come back. Before the 6 weeks end, there are signs. Her wings, which were translucent and structurally complete when she first flew from the hive, begin to accumulate damage from the constant friction of flight. Microscopic tears in the membrane, fraying at the edges, a gradual loss of the stiffness that makes controlled hovering possible. By the final days of her life, she is flying on wings that are visibly worn, operating at reduced efficiency, covering the same distances with more effort. She does not adjust her routes. She does not slow down or reduce her workload as her wings deteriorate. She flies until she cannot, and then she stops. In those 6 weeks, she will fly a total distance equivalent to 1.5 times around the circumference of the Earth. She will visit between 500 and 1,000 flowers on each of her foraging days. She will produce, across the entirety of her 6-week life, approximately 1/12 of a teaspoon of honey. 1/12. The jar sitting in your kitchen required 12 bees to give everything they had. And built into those 6 weeks, available to her at any moment but almost never used, is the sting. The hive treats the sting as a viable option in one specific circumstance: genuine, immediate threat to the colony's survival. A bear at the entrance, a sustained assault, an emergency that justifies the trade. In every other situation, every foraging flight, every encounter in every garden, every bee that has ever flown too close to a person and then moved on, the calculation goes the other way. 6 weeks is too short to spend on you. The lavender is waiting. Research tracking sting incidents relative to bee-human encounters in residential and agricultural settings consistently finds the same pattern. The overwhelming majority of stings happen in specific, documented circumstances: a bee trapped under clothing, a nest disturbed during garden work, someone who stepped barefoot onto a forager resting on grass. The incidental encounter, bee flying past a person, bee foraging near a person, almost never results in a sting, because the calculation almost never warrants one. She has 6 weeks. She flew close to you, processed your presence in under a second, classified you, and kept going. That was 6 weeks being used on something that mattered to her. You were not it. There is something in this that I find I cannot frame in a way that feels proportionate. A creature with a lifespan shorter than a summer, carrying a defense system so costly that deploying it once ends her life, making a real-time assessment of every large object she encounters in the course of a single foraging flight, and arriving at the correct answer consistently across hundreds of encounters per day in a fraction of a second each time. Flying past people in gardens, past children running, past dogs, past lawnmowers, past every large moving object in a 3-kilometer radius of a hive that might contain 50,000 individuals, and stinging so rarely that most people who have spent decades around bees have never been stung during a normal garden encounter. Not because bees are docile, because the calculation is sound, because the life is worth more than the response, because the flower matters more than you do. I don't mean that as an insult. I mean it as an accurate description of a priority system running in a brain the size of a sesame seed and getting the right answer every day, all summer, until the wings wear out. Right now, while you're watching this, a bee near your house is on a foraging route. She will pass close to something large, a person, a dog, a parked car, at some point in the next few minutes. She will assess it and move on. The assessment will take less than a second. She will not think about it again, in whatever sense bees think about things. She will continue toward the flower she came for. Step outside this week and find one. Not to approach her, not to test anything, just to watch. Watch the moment she notices you, the fractional pause, the slight adjustment of trajectory, and then watch her continue. She has classified you. She is done with you. Whatever energy she has today is going toward the flowers, the pollen, the route she will dance for the hive when she gets back. She has 6 weeks. She spent a fraction of a second of those 6 weeks on you, arrived at her conclusion, and moved on. I've spent considerably more time than makes sense thinking about that, about what it means to be assessed and dismissed that quickly by something that precise and that temporary and that entirely focused on something else, about the fact that every bee that has ever flown near my face and moved on was using the calculation that her life was worth more than the response. That's not threat. That's priority. The lavender was the priority. You were the thing in the way. I don't think just a bee means what I thought it meant. Leave a comment if this changes the next bee you see. Has one ever flown so close that you held completely still and then it just moved on? Tell me exactly what that moment felt like. I read everything, and those moments are the ones that stay with me longest. Subscribe. New video every week. See you next time.